What up?
Hey.
So,
for
question?
Yeah, it started.
You're good.
So for question 1, we're supposed to draw.
Sorry.
I'm sorry. We're supposed to draw an intermediate stage of DNA replication in Bacterium E. coli. Draw 2 replication forks proceeding from the single bacterial origin of replication. It may be easier to draw a linear DNA molecule rather than a molecule. So that's what we did. You can barely see it, but so we have the
record.
Thank
Close
you.
up.
So we have the leading strand, which will be going from 5' to 3', and we also have the lagging strand, which will be going 3' to, that should be 5'. And okay, and the origin of replication, we're going to have that on this DNA strand going from 3' to 5'. DNA polymerase is we're going to have DNA polymerase, and following that, we're going to have topoisomerase. And then we're going to have Okazaki fragments on these segments, and then we have our RNA primer. And on the lagging strand, we also have DNA polymerase 3. And following that, DNA primase and DNA helicase. And the movement of the fork is going that way to the left.
Oh, good. Take this back down. All right, so for 2, here's all this stuff. How do I scroll up?
Here, excuse me.
Okay. So we got DNA polymerase alpha, and that's the protein complex that synthesizes primers in eukaryotes. For B, we got DNA A, and that's the protein that promotes the separation of the AT-rich sequences within the ORC. C is DNA polymerase 3 epsilon. This subunit of DNA polymerase 3 contains proofreading activity. Then D, DNA polymerase epsilon. This protein synthesizes the leading strand eukaryotes. E is TUS. This protein displaces DNA polymerase 3 from the chromosome to terminate replication. F, DNA polymerase 1. That's the protein that has 5' to 3' polymerase and 5' to 3' exonuclease activity. Then G, DNA gyrase. That's the protein that introduces negative supercoils into the DNA ahead of the replication fork. H is ORC. This protein binds directly to the ARS elements. I, SS, BP, those are the proteins that prevent DNA strands from annealing during replication. And then J, DNA ligase, is the enzyme that seals Okazaki fragments in the continuous strands of DNA. And then for number 3, get that pulled up. Enzymes that consume ATP during DNA replication, we found that they were DNA helicase, topoisomerase type 3, DNA primase, DNA ligase, and MCN helicase. Then B, 5 more enzymes that consume DATP during DNA replication. We got DNA polymerase 3 and 3 epsilon, 3 alpha, and 3 delta. Then DNA polymerase number 1. C, the 5 enzymes that have 3' to 5' exonuclease activity. We got DNA polymerase. Let me look real quick, sorry. DNA polymerase 1, DNA polymerase 3, epsilon, delta, and alpha as well. D, indicate 1 enzyme involved in replication that uses DNA as a template to synthesize RNA. We got DNA primase. And then E, for the last one, indicate 1 enzyme that uses RNA as a template to synthesize DNA, and we got telomerase. That's for 3.
Okay. So for number 4, so the Sister Mayo posted a video about how to do this, but we'll still explain it. So it's asking you, it gives you a single-stranded DNA molecule, and it's asking you to come up with the anti-strand that's similar, that matches with that DNA strand, but including the different nucleotides that it has listed. So for A, it asks to do it with DATP, DCTP, DGTP, and DTTP. And so if you were to make the anti-strand to that, it'd be 5 prime, starting with ACT, and then GAT, GGT, CCT, GCT, and AT to 3 prime. For B, it's the same situation, except for the cytosine, it's the cytosine monophosphate, and because it's a monophosphate, that means it's not ideal for the DNA strand, so it won't bind. So for that one, 5 prime A to 3 prime. So it's a really short strand. For C, again, the same situation, except for the DTTP, it's actually UTP, and since it's not deoxy, then it's not going to be able to build the backbone of the DNA, and so that strand will stop after C, so it'll be AC, 5 prime to 3 prime. And then for D, it's the same situation, except we have GTP, so again, it's not deoxy, so it doesn't have that sugar for the backbone. So then this strand will be 5 prime ACT to 3 prime. So basically, to learn from this is if it doesn't have the necessary aspects of that nucleotide necessary for the DNA strand, it's not going to bind, and it'll just stop as soon as it's needing that nucleotide.
Okay, for number 5. A is asking which of the above proteins are found in prokaryotes. So going off of the readings, what we were able to find there, we have DNA A, that protein, DNA gyrase, DNA primase, DNA polymerase 1, DNA polymerase 3 alpha subunit, since it specified that, and the TUS. For B, it said in the mouse, MUS musculus. Since it's a mouse, it's eukaryote. You can expect to find DNA primase, DNA polymerase alpha, and as well as DNA polymerase 3 epsilon. Also, you can expect to see in this, since it's eukaryote, a CDC6. But also on the list, you have the PCNA and the telomerase. For C, it is asking which of the above proteins are involved or is involved in chromosome compaction, and for that we just have DNA gyrase. For D, which of the above proteins is involved in the initiation stage of DNA replication? For those, we find the CDC6 and the DNA A. And then for E, which of the above proteins are involved in the termination stage of DNA replication? For those, we have the MCM helicase protein as well as the TUS. So that is all for this week. Until next time.